This part of the module, we'll be looking at verifying trig identities. So just work a few examples for you, show you how this works. So what I want to do is show that this is equal, that I can make this side equal this side. And then I have verified the trig identity. I've shown that they're equal. So if you got your formula sheet, take a look at that, and you can see that this is a trig identity. So we're going to bring down this secant squared, and 1 minus cosine squared is sine squared. And I can change secant squared to 1 over cosine squared, right? You got to remember all these identities. That's what makes this difficult. So much to remember. So change secant to 1 over cosine because they're reciprocals. And 1 times cosecant times the sine would be sine over cosine squared. And that is an identity in itself. And we've learned that sine over cosine is tangent. So I have verified this identity. And that's how it works. You just got to be familiar with your trig identities. So, get your formula sheet out and just practice memorizing some of these forms. So do another one for you. Okay, so tangent. So just look at some of these expressions and how can I rewrite them and try to simplify them down to be, I'm trying to get this left side to be secant. So I can change tangent to sine over cosine. That's an identity. Time sine. And there's really not a lot to do with the sine and cosine at this point. So it's this times this. Let me give myself a little more room here. So sine times sine would be sine squared over cosine plus this cosine. And since it's just cosine, it's also the same as cosine over 1. I'm going to make it a fraction because on the other side I have a fraction too. So I'm adding 2 fractions. And what do you do when you add 2 fractions? You have to get a common denominator, right? So the common denominator would be cosine. And since this term already has that common denominator, we can just put sine squared on top plus, I need this one to have a common denominator of cosine. So we multiply top and bottom by cosine. 1 times cosine is cosine, so I now have the cosine in the denominator. And cosine times cosine would be a cosine squared. And look at your formula sheet, your trig identity formula sheet. What is sine squared plus cosine squared? 1. So I have 1 over cosine, which is what? What's the reciprocal of cosine? Secant. So 1 over cosine is secant, which is what I was trying to verify in the first place. I'll redraw that arrow. Oh, well, it doesn't want to stay today. Okay. I'll just move on to the next one. So we got 1 minus cosine squared. I'll put an x this time. The ones in your exercises have x instead of theta. Okay, so this one doesn't look too terribly bad. Just give myself a little more room. Well, first thing I notice, right there, there's a trig identity. I can change that to sine squared over cosine squared. And I'm done, right? Because sine over cosine is tangent. So that one was pretty simple. Okay, so not much going on with that one. Take a look at another one. So we'll have secant x over sine x 1 minus cosine equals tangent, okay? Well, just based on the one we just did, right there, that's what? So let me rewrite this side and change this 1 minus cosine squared to a sine squared. And if you notice, that sine could cancel with one of those sines. So now I have secant x times 1 sine. Because again, that canceled with one of those. That's 2 sines there. That's sine times sine to get the sine squared. So is there anything else I can change or write in a different form? And the answer is yes, right there. What can I rewrite secant as? 1 over cosine. So if this is 1 over cosine, we would then have sine over cosine, right? And what is sine over cosine? Tangent. So that one was verified as well. So how are you going to do this? Are you going to have to type out all the steps when I give you your 10 questions to practice with? You know, I tried to think of an easy way to do this because I know this can be pretty difficult because we haven't had face-to-face lessons on this. So what I decided to do was make them true and false. So you're going to have 10 equations, and you're going to decide if they can be verified as trig identities or not. So all 10 of your questions are true and false questions. So let me give you a few examples of what those would look like. So you're going to decide if the equation I give you is a trig identity. So let's take this one for example. Okay, so I'm going to give you a trig equation, and you decide if I could simplify this side to be this side. You're going to decide if these identities can be verified or if they're not, if they're false. So let's work through this one. Okay, so not much to do here. Just bring down that secant. I know I can change tangent to sine x over cosine x. That's one of our simple identities. And I'll just leave the sine x. So just bring it down. Okay, I got a sine times sine. So that's sine squared over cosine. And I can change secant to 1 over cosine. And now I'm back in that situation where I need a common denominator. But I already have one because both denominators are cosine x. So I have the common denominator. And just bring over everything on the top. That's 1 minus sine squared. You look at your formula sheet, 1 minus sine squared, cosine squared, right? And this cosine would cancel with one of those cosines, leaving cosine. So this identity is the same as cosine, not sine. So this one's false. And that's how you're going to work through your examples today. So I give you the identity and you decide if it's true or false identity. Okay, so let's go through a couple more. And again, it's real important that you have that formula sheet. Oh, I'll use theta. This one. Okay, you're looking at your formula sheet. You'll see that that is tangent. So we got secant squared over tangent squared. And I'm trying to show that that equals cosecant. And remember, these are true or false. Okay, your examples are true and false. So that way you don't have to type all these steps, and it's just kind of easier online to do it this way. Okay? So I'm going to rewrite secant as 1 over cosine squared. I'm going to rewrite tangent as sine squared over cosine squared. And those are just simple identities. I'm just rewriting them in a different form. They're equal. Secant squared is the same as 1 over cosine squared. And I'm dividing by a fraction, so I want to multiply by the reciprocal. This cosine cancels with this cosine. So I'm left with 1 over sine squared, which is cosecant, right? 1 over sine is cosecant. So this example turned out to be true. And got time for a few more here. And you're going to see X in your examples. Okay, so is this true or false? So let's get into it. You look at your formula sheet. You'll see that this is secant squared. That's right on your formula sheet. Very basic identity, Pythagorean identity. So now how can I rewrite stuff? Well, this cosecant squared, we could write as 1 over sine squared. And this secant squared, we could write as 1 over cosine squared. And it doesn't look like there's any way to make this equal cosine squared, right? So, false. I just can't multiply sine times cosine and get cosine. So this one worked out to be false. Okay, next example. Is this true or false? Is this a true identity? Does this equal this? And the answer is yes, this is true. It's right on the formula sheet. This is copied right off the formula sheet. So that's just a basic identity that you need to know. So I'll start wrapping up the video now. And I'm also going to put a short video to every question in this lesson, the verifying trig identity lesson. There won't be any audio. You're just going to see me working the problems out. I'll work them about halfway through for you if you need help. So click on that video in each question if you're having trouble, and I'll work it maybe halfway and kind of let you pick. And remember, there's no audio to it, so you're just going to watch me work the first few steps for you. Okay, so I hope that helps you get through the lesson. And remember, you're deciding if your identities are true and false in this lesson. Okay, good.